Right, let's head straight into it, I think. So in these next two examples, I'm going to run through them a little bit quicker. In the first video, we went through, just a bit more detail and we're setting up. So here we go. Here's our one. Let's clear our calculator. Let's get rid of it and go for it. Sam starts saving at the age of 20 for his pension. He pays 700 Rand into a pension fund starting on his 20th birthday. Interest is calculated 11.4% per annum compound monthly. Okay. So we got the idea, the story. Certain person at 20, they start paying money every month so that when they retire, they've got a whole lot of money to withdraw. Okay. Calculate how much money he will have saved by the time he turns 60, assuming that his last payment is made 1 month before his 60th birthday. So 1 month before, we're just going to have to keep our wits about us. So we're going to use our formula, right? So this is going to be F equals X. Okay, well, he's putting 700 Rand in each time. We've got 1 plus interest rate, 0.114 over 12, because it's done monthly. And I'm going to leave the N because that's going to be a nice question mark that we're going to come to now. And we've got our zoop minus 1. It's almost easy to forget that, but I said, come on, we're going for it on this one. 0.114 over 12. Okay, so the question is, what is that question mark? How many compounding periods are there in this time? Okay, so perhaps your logic is, well, it's 20th birthday and the last payment's 1 month before his 60th. So on the birthday till 1 month before, we'll just think if you did it for 1 year and you did it at the beginning of each month, you would still do it 12 times for that year. And then as you hit your next birthday, that's the 13th month. So pause and just jot that down in a little timeline to help you see that if you can't see it. The idea of, if you put it in January and your next birthday is in January and you're putting it in at the beginning of each month, December you're going to put at the beginning of the next month, and then the last payment's made 1 month before the birthday, so you've got 12 of those, and we're doing this 40 times. So I'm just going to write here 40 times 12, because that's too big a number for my little head to manage. So, yeah, as I said, jot down all that weird stuff that was happening above and behind my head. Just write it down. Okay. Now, the thing is, this formula is not complete. Doesn't quite work out for Sam saving because the last payment goes a month before his 60th birthday. So what do we need to add to this formula? What do we need to, what we need to do more to this formula to get our final answer? Well, we're going to take all of this. That's what happens 1 month before his 60th birthday. So to keep this growing for 1 more month, we can't just change this to 41 or something like that, 41 years, or add 1 here, because he's not putting another 700 Rand in on his 60th birthday. So we're going to take this whole thing here and we're going to multiply it by 1 plus 0.114 over 12. In other words, we're going to invest this whole thing for 1 more month. So that's our thing, and we're investing it for 1 more month. So that to the 1. And then you can punch that into your calculator. We went through in the first video a whole lot of different strategies of putting this into your calculator. So I'm actually going to hit a little mini pause, run away, and then you can do it yourself. And just like magic, we are back. So my time out anyway. So here we go. I put all of this stuff in my calculator and I did it with all my variables and that. And I get this lovely large number of 6,884,120 Rand and 61 cents. Now, if you worked it all out and you took maybe a more long-winded approach, as long as you're not way out in terms of your Rand, if you're a few cents out because of some sort of rounding off along the way, not a big issue, but it should be pretty much that. So 6 million, which is, that's quite a It's a nice idea, that idea of you put 700 Rand away every month and you've got almost 7 million Rand. Now, I know it's 40 years later, and yeah, I say this not having saved for a little bit, and then I did start saving every month, and it grew very quickly. So, yeah, thumbs up when you get a chance to save. But, that sounds like old person speak, right? So, here we go. Calculate how much interest you would have earned over the 40-year period. So for this one, all we need to look at is, well, how much money did he put in? Or I say he. Oh, it does say he here. Sam could be he or she, or it could have been they if said person wanted to be called they, but our example says he. So how much interest, in other words, how much money did they get over that period? So I'm going to leave you to work it out and then be back with the answer. And we appear. Calculator has changed. We press equal, and that's what we get. 6 million. So all we needed to do was take this amount here and subtract. So I guess showing our working would be nice. 6,884,120,61, and subtract, if you just, that Sam did put in 700 Rand per month for 40 years. And when we put that into the calculator, we get 6,548,120 Rand and 61 cents. In other words, didn't actually put in, say, 300,000 Rands worth, and, you came out with 6.5 million Rand more. Interesting enough, let's head into our final example for today. So, the story time. Angie deposits 1,000 Rand into a savings account each month. Interest is calculated at 7.5% per annum compounded monthly. How long will it take until she has 500,000 Rand in the account? So maybe just quick idea. We'll move that out the way, because obviously I never know where things are around here. Up there, right? So, write down how you think you're going to solve it.
Write it down.
Quite scary, eh? Okay, so write down your ideas. Okay, so let's see. I'm very interested to see if anyone talked about kind of working backwards, because that's how we talked about it before. The idea of, well, we're going to put in the equation, we're going to work backwards to find something. So, but maybe that was like one of those previous examples. So we want to see when there's 500,000 Rand in the account, if you're depositing 1,000 Rand into the account every month, and 1 plus interest is 7.5% per annum compounded monthly, 0, not 0.75, 0.075 over 12. Now we don't know this, so we're going to put an N, and our interest rate at the bottom is still 0.075 over 12, and there's our equation. Okay, so we just need to solve for N. Now, you may take however long to solve this. I'm going to kind of do it bit by... I was going to say, I don't need the calculator that big. Go away, calculator. No, now we're in the wrong place. Oh, well, we got them. So I'm going to do it bit by... I was going to say bit by bob, but bit by bit. So we got 500,000, 500, 1, 2, 3, divided by this 1, 1, 2, 3, and by 1,000. So 500. I'm just going to kind of show my steps a little bit, that we've got 500 equals that. Then we want to multiply by that denominator. So this time I'm not using any of my fancy variables, and so that's why I'm leaving this all in at the moment. And so I'm going to multiply by the denominator, 25 over 8, and then subtract 1. So I want to plus 1 on each side. So we're going to plus 1. So I've got 33 over 8. So after all of that, 33 over 8 equals, and we're just left with 1 plus that. Might as well work that out. 1 plus 0.075 over 12, 161 over 160, I think it says. Oh, right. Oh, right. Wrong buttons. Buttons, get there. Okay. So I was just kind of working through this in the calculator. 500,000 divided by 1,000. Then multiply. So first divided by that. And then in the next step, just to make sure that you got what I was doing, then I multiplied by that. And as the last thing I wanted to do was plus 1, so that all we're left with is this bit over here, which is this bit over here, once we have said to the power of n. Okay, now we want n to be the subject of the formula, and it's in the exponent. So what can we use? Well, we can use logs. Yay for logs. Now we got logs. And remember, one of the purposes of logs is to get the exponent to be the subject. The base stays the same, 161 over 160 of 33 over 8. So just remind yourself of how logs work. And remember, the way that we had thought about it before was kind of one of the key points is that we want the exponent to be the subject, and the base stays the same, and then the log of that thing. And that was in our fancy intro video, that part there. So into the calculator that goes. And so I'm just going to do it kind of straight up like this. 161 over 160. Kind of, and if I were in another mood, maybe I would have put this in variables. But the reason I'm not is that I can see everything quite clearly on the calculator there. So I don't have to, scroll up and down. Everything is quite clear. So when I put it in, there we go. I can see 227, whatever, 4. And these are months because this was compounded monthly. So it says month, it says how long. So if you wanted to, I guess you could say this is approximately 19 years, I think, if you divide just once. Divide by 12, 18.95 years. That's about 19 years. So whichever answer. So that was fun. That was a bit of logs. Yeah, that was it. So I think what you need to do
is make it maths. Just make it maths. Come on, just make it maths.